me Nathaniel, and today I'll be giving you a video in chemistry where we're talking about the complete guide to your chemistry syllabus for JAMB and the various major parts of chemistry where you need to read to succeed excellently. Now, without wasting much time, let's delve into the matter at hand. So, now in your chemistry JAMB examination, you have different aspects, and one of those aspects is matter. So, you need to understand what matter is. Matter is anything that has mass and occupies space. So this video that's talking about matter will not go too deep, but it will tell you that this matter, they are basically any substances that have mass and occupy space. So they can consist of elements and compounds, they can consist of mixtures. So for this matter, they have their own specific properties. So a matter has what is called physical properties and chemical properties. So and then when we talk about physical properties, we talk about the properties that are easily reversed and easy to change, and they don't produce permanent products. But chemical properties of matter, anytime you mess with the chemical properties of matter, they always produce permanent results. And in physical properties, we often involve in physical separation techniques, and those involves evaporation, centrifuging, distillation, fractional crystallization, and precipitation, and so on and so forth. So these are reversible methods. These are methods of separating mixtures and combining them. So basically, these are physical separation techniques. But chemically, there's basically little or no way to separate a substance that has been chemically reacted, that has been chemically acted upon. Then we have atomic structure. So the atomic structure of the substance is basically the number of atoms, the number of atoms, the number of atoms, the shape of the atom, the shape of the molecules, the polarity, and so on and so forth. So basically, when we talk about atomic structure, we need to talk about the shape of molecules. Shape of molecules are affected by polarity, which is also affected by the number of lone pair electrons, or you can also call it the number of the electronegativity difference in the atom or molecules. So in atomic structure, we'll talk about the structure of the atom, the number of atoms, the bond, the chemical bond, the bond angle, and all the rest, and so on and so forth. So you need to understand atomic structure, because here you'll be having questions on bond angles, and even in organic chemistry where you talk about carbon bonds, you need to understand the atomic structure so you know the hybridization and the bond angles formed. So now let's talk about periodicity of elements. I know you've probably heard of periodic tables in your early SS2 education, and then periodic table was all about the arrangement of elements which are the function of their atomic numbers. So originally it was in when it was proposed by Dimitri Mendeleev in some centuries ago. Actually, it was based on the mass numbers, but now periodicity of elements is based on the atomic numbers. So periodicity of elements simply means that the elements are progressively having properties that change based on their atomic numbers. So and that's part of the things you will need to understand. You need to understand periodicity, because in JAMB they often ask questions on which group the element belongs, which group, which period. And then if you cannot memorize, you cannot always remember the group, because this if you have something, and if you have if you draw the chemical structure, for example, when we have something like oxygen, O2. So let me draw the chemical structure of one of these oxygen. If we talk about the electronic configuration, we'll talk about the nucleus, then we'll talk about the first shell, second one. So we have two in the first, then we have eight. But then oxygen has 8 electrons. So if we take 2 from this first, then we'll be left with 6. So we'll take the 6. So in the previous video, I was talking about organic chemistry, and I was talking about the fact that oxygen has 3 lone pair electrons. So and because of this oxygen can actually combine in a number of ways. So 1, 2, 3, 4, 5, 6. Yes. So basically, oxygen combines in a number of ways. And when we draw the subshell notation, we have something like this: 1s2, 2s2, 2p, we have 2p4. So what this means is that the oxygen, if you have the the letters. You look at the numbers. Number 2, number 2. This number 2 stands for, this number S stands for the block. S stands for S block, and S block, in S block we have metals, then we have P block for non-metals. But then this power here stands for the group. So anytime you have letters are the same, you add the powers. So that will be, this is 2 and this is 2. So we add the power 4 and 2, that's 6. So oxygen is in group 6. Then the period is in period 2. So the number stands for the period, then the power stands for the group, and then the letter stands for the block. So S block is for metals, P block is for non-metals, D block is for transition elements, then the F block is for alternate and lanthanide series. So basically you need to read up all this stuff in your book. Then we also have, let me draw the 1s, 2s, whatever. We'll also start from 1s, then we go to 1s only has 1, only has s, then we have 2, the group, or rather the period 2 has s, the period 2 has 2s, and then it has 2p. Then we have 3s, 3p, 3d. We have 4s, 4p, 4d, 4f, and so on and so forth. So basically you have an arrow, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, so and so on and so forth. So that shows that 1s, after 1s you have 2s, after 2s you have 2p, after 2p we have 3s, after 3s we have 3p, and after 3p instead of 3d we have 4s. So that means the 4s has that means the 3p, the 3d, after 3p we have 4s, right? That means this 3d has more energy in its in that orbital than the 4s. So basically I'm talking of all these atomic energies and bond energies and all the rest. So you can also read that up for your exam examination. Then next we'll talk about chemical bonding. Chemical bonding is based on the types of bond forms, and the types of bond is related to the electronegativity difference. Now, anytime you have an electronegativity difference of above 5, when it is greater than or equals to 5, it is an electrovalent bond or ionic bond. When it is 5, it is polar covalent. Then when it is less than 5, it's a polar bond. It's a covalent bond. So less than 5 stands for covalent, then 5 stands for polar covalent. Then with 5 and 20, between 0.5, sorry, it is actually 0.5. So less than 0.5 is covalent, 0.5 is polar covalent, then above 0.5 is electrovalent. So the more the electronegativity difference between the combining elements, and that means that there will be a greater chance for the bond to be polar. So, and those polarity is what's called bond angles. So when you talk about chemical bond, you have to talk about bond angles, and you have to talk about bond energies. So now bond energy is just like when you have two atoms coming together. Now bond energy is the amount of energy required to make or to break those bonds. So when you have two atoms together, or radicals, now those bonds are formed between their molecules due to the electronegativity difference, and the electrons are just and protons, they are just like positive and negative, just like opposites attract. So when the opposite part of one atom combines with the opposite part of another, and those opposite parts, they are also known as poles. So we have poles, and those poles, when they combine together, they kind of attract. That's why we have and when that attraction is much, we have a very, very strong bond, and because of that we have electronegativity and electrovalent bonds. Those electrovalent bonds, they are formed in metals. That's why anytime you see anything that is hard, strong compounds, they are electrovalent. Then when we have liquids, they are not very electrovalent. They are probably polar or polar covalent. Then when we have gases such as naphthalene, so all those ones are majorly polar compounds. But in electrovalent bonding, we always have ions. But then in covalent bonding, we always have molecules. So basically, you need to read up chemical bonding, and then we have descriptive chemistry. Descriptive chemistry is talking about the description of various elements and compound and their compounds. So we have descriptive chemistry on hydrogen, descriptive chemistry on metals and their compounds, descriptive chemistry on oxygen, properties of oxygen, preparation of oxygen. So you have to talk about in descriptive chemistry, you talk about the different common compounds in chemistry, like hydrogen, oxygen, silicon, phosphorus, and all the rest. And then you talk about the separation of all the manufacturing of them, the reaction, the chemical reaction, the physical properties, chemical properties, the compounds forms, and all the rest. So those are parts of the things you need to understand in descriptive chemistry. So then we have stoichiometry. So in stoichiometry, we'll talk about the mass and the volume in which reactants formed, and then the mass and the volume by which products are produced. So stoichiometry is talking about when you have a reactant will be formed in a particular mass and volume, while a product will also be formed in a particular mass and volume. For example, for the question of production of ammonia in the Haber's process, we have N2 plus H2 to give a reversible reaction. So NH3. Now this N2, when we balance the equation, we have something like 3. Let's have 3, and then 3. Sorry, let's have 2 here. To balance the equation, 2. We have 2 here. 2. And then we have okay, if we try balancing this equation, we'll have some N2 NH3. So we have N2 NH3. Let's put it here. So 1 molecule of nitrogen will combine with 3 molecules of hydrogen to form 2 molecules of ammonia in Haber's process. So and this kind of equation is representing stoichiometry, because nitrogen is a gas, right? So when you have gaseous nitrogen combining with gaseous hydrogen to form gaseous ammonia, those nitrogen and hydrogen, they are the reactants, and then the ammonia is a product. So you have the moles, because now you have knowing that 1 mole of nitrogen combined with 3 moles of hydrogen gas to give you 2 moles of ammonia. So that is what stoichiometry is about. So you need to make use of the equation reaction to substitute for other values of the masses or volumes. That's what stoichiometry is. So you need to understand. Then we also have kinetic theory of matter and gas laws. So in kinetic theory of matter and gas laws, we talk about the fact that we have different laws of gases, such as Charles' law, Boyle's law, GlEDUzownõ's law, Avogadro's law. So on all these laws, Charles' law, for example, states that the volume of a given mass of gas or a fixed mass of gas is directly proportional to its temperature, providing that pressure is kept constant. Then Boyle's law states that volume of a given mass of gas or a fixed mass of gas is inversely proportional to its pressure, and that's pressure. That's a change in pressure. So the change in volume is inversely proportional to the change in pressure for a given fixed temperature. Then we have Joyne's law, the Joyne's law, or is combined law, which is GlEDUzownõ's law of combining volume, which says that which talks about chemical reactions, that when 2 or more chemical substances together, they react in volumes that are in simple ratios to one another and to the product forms if gaseous. Then we have Avogadro's law, which says that equal volumes of all gases at the same temperature and pressure contain equal amount of molecules. And then Avogadro's constant, which is 6.02 times 10 to the power 23, also carries that every mole of a substance contains that particle, and that Avogadro's constant is also equal to 1 mole, and 1 mole is also equal to the amount of substances in exactly 1/12 the mass of carbon 12. So all this and many more, these are basically the kind of things you need to understand in your kinetic theory of matter and gases. Then we have energetics. Energetics talks about the movement of gases, the movement of substances, and even the rate of reactions. So rate of reactions, you have your rate law. So in most of the time in your JAMB examination, you don't need to go too deep into rate law. So but with energetics, you need to understand the factors affecting rate of reaction, what such as concentration, temperature, and change in pressure, change in surface area, catalytic addition, and all the rest. So that is part of energetics, part of the exam. Then we have chemical kinetics. So for chemical kinetics and chemical equilibrium, chemical kinetics is related to chemical equilibrium. So in chemical equilibrium, you need to understand the various factors affecting equilibrium. For example, in equilibrium of a reaction is known as dynamic equilibrium, and equilibrium is only achieved when the rate of the forward reaction is equal to the rate of backward reaction. So in dynamic equilibrium, what it means is that even though there is still movement of atoms, but the movement of atoms is random and there's no difference in in the let's say the ionic substances. So there's an equilibrium, and that's when it comes to the reaction, the forward rate must be equal to the backward rate. Then we have chemical dynamics or chemical kinetics. Then we have acid, base, and salts. We have electrochemistry, which deals with electrolysis, and then the electrolytic cells. We have nuclear chemistry, which deals with the radioactivity, properties of radioactivity, such as alpha, beta, and gamma rays, and all the rest. Then we have organic chemistry. So at present, I have a series in this channel which I'm doing on organic chemistry, which I'll cover on every part of organic chemistry. But then you have to understand impact nomenclature of organic compounds. You have to understand hydrocarbons, other organic families, and functional groups, bifunctional groups, and organic giant molecules. So all these are part of the things you need to understand for your organic chemistry. And I assure you that this channel is going to be here for you to make you understand the various aspects of organic chemistry. So just like, share, and subscribe the video, and then share the video to every other person that will to be of advantage, so that you can make an impact and be a light of knowledge to your world. So now, lastly, you also need to understand industrial and environmental chemistry, where we talk about fine chemical, heavy chemicals, and all the rest. So with that, we've come to the close of this so but before that, you also need to have some knowledge of experimental chemistry, which talks about qualitative and quantitative analysis. So, and you need to understand that because JAMB also asks questions on testing for the various cations and anions. So, and then you can always find that in your chemistry textbooks, but you need to understand it. And hopefully this channel I will be able to put some content on that soon. So, but thank you for watching, and I wish you success in your